Okay, so this is Objective 2.1, and our goal with Objective 2.1 is to analyze graphs of quadratic functions, write quadratic functions in standard form, and use the results to sketch the graphs, find minimum and maximum values of quadratic functions in real-life applications. Okay, so you can copy those objectives down, pause the video. That's not just me making you write down a bunch of stuff. Those are the things I want you to actually be able to do by the end of this unit. So in order to do those things, we have a few things we need to define. Number one is, hopefully you remember, but since we've talked about it with our parent functions, but today we're all about the quadratic. So if we have a function, we say standard form of the quadratic is ax squared plus bx plus c with a does not equal 0, meaning there has to be an x squared term. So it's that x squared being the degree of the polynomial that makes it a quadratic function. So when we graph a quadratic, it makes a shape called a parabola. And all parabolas are symmetric with respect to their axis of symmetry. So we're going to be able to give the equation of the axis of symmetry, or sometimes we just call it the axis. And then the point where the axis intersects the parabola is called the vertex of the parabola. And we are going to spend a lot of time with the vertex. So let's look at a few basic parabolas. The parent function is f of x equals x squared. And so let me get a piece of graph paper. Okay, so I've got my graph paper and I've sketched my coordinate plane. So now I'm just going to sketch the parent function. So 2, 4, and then 3, 9, and negative 2, 4, and negative 3, 9. There's my standard opening parabola, and for that one we say f of x equals ax squared, and then we say a is greater than 1. So that's your standard with a positive number upward opening parabola. So if we wanted to take a different color and then graph, I'm going to write it down here, f of x equals ax squared, except a is less than, instead of a is greater than 1, I should have said a is greater than 0. So any positive number. And so then for this one would be a is less than 0, and then that would be an inversion. So 2, negative 4. There we go. Okay, so that's what happens if a is less than 0. Then for the general form, like say if we had f of x, let me go back to my purple, equals ax squared plus bx plus c, as long as a was still positive, we call that the leading coefficient, then we would still have our upward opening parabola. And here, if we have f of x equals negative ax squared plus bx plus c, as long as a is less than 0, then we still have, on our leading coefficient, then we still have a downward opening parabola. So let's talk about shrinks and stretches. So do I want to use my same set of graphs? Yes, because I don't have all that much room. Okay, so if I give you a g of x that is a fraction, a fractional a, it's not inside the parentheses, we are going to be looking at a vertical shrink, and 1/3, that's a shrink 3 times as big, so it's kind of a reciprocal thing. So we would have this wider opening. and then a vertical stretch. Notice my coefficient, I'll call it h of x, and let me give it a different color. H of x equals 2x squared. Then that would give me, I'd go 1, 2, 8, so it would be a skinnier parabola, and it would be a vertical stretch. And so I could demonstrate my horizontal stretch and shrink down here, but in the interest of saving time, I will let you do those. You can graph those. We'll do a horizontal stretch. And think about what would have to change in your equation. Well, we'd have our a here, and it would be less than 0, so that would be a negative if I wanted to be able to graph it down here. And then to do a horizontal stretch, well, then that would be at some fraction, 1/4, say, 1/4 x squared. So I would have to take x and multiply it by 4 to get it to be 1 unit down. So there would be my horizontal stretch. It would go out wider. Then a horizontal shrink. A times 2x, we'll say, squared. That'll be a horizontal shrink. And that would just make a narrower parabola. Okay, so what else do I need to tell you about? So let's just talk about the transformations of this function. So next page. In example 1, if I gave you f of x equals negative x squared plus 1, and I could ask you what the transformations are and what the new graph looks like. And then I'm going to go ahead and do 2 in this problem. I'll say g of x equals x plus 2 squared minus 3. So knowing what the parent function is, and then to be able to graph it, is something that you should be able to do in this unit. So let's talk about the transformations. We have a k value, so we would be going up 1, and then we have a negative sign. So we're going to flip over the x-axis. So let me get my axes and my parent function. So I'll do the parent in red this time. 1, 2, 4. So the flip and the up 1. So I'm going to move the vertex up 1, and then I can, and then 2, 4. So you see how I keep sketching that same proportion, just so I can keep the opening at the correct width. So for g of x, we have the same parent function, but then we need to look, and we have an h, and we have a k. So h is plus 2, so it's going to be left 2, down 3, no flip. So I go left 2 and down 3, and I can make a point, and that's my vertex. And then I'm just going to do the standard opening. So 1, 1, and then over 2 and up 4. And there you go. So I want to talk more about, your book calls it standard form. I call it, it's either called vertex form or HK form. So I don't want to deviate too much from what your book does. So we'll call standard form of a quadratic. And so this is a review from your transformations unit. So we have our A value, which is to stretch or compress. We have our H value, which is horizontal, shift. And we could make a note that negative is right, or minus is right, plus is left. Then here we have our vertical shift. So sorry. Vertical shift, and this time positive is up, negative is down. And I'm at 10 minutes, so I need to go through an example where we use completing the square to get a parabola into that HK form. So we want to identify the vertex. So what I need to do is complete the square to get this thing shifted around and moved into HK form. So I'm going to demonstrate completing the square, and then we're going to have to practice that quite a few times because I have a real feeling that that's a skill that you may have forgotten from Algebra 2. Okay, so to complete the square, I want you to recall that a perfect square trinomial is some binomial that when you square it, you end up with an x squared term, and then I look at this 4, and if I'm picturing the foiling that's happening, I have a 4x and a 4x, so I always end up with double of whatever my constant term is, and then I have a perfect square as my C value. So this is a perfect square trinomial. This is our goal when we're completing the square. So in order to do that, number one, we need to just kind of focus on these first two terms and get our leading coefficient to be just x squared. So I'm going to factor out a 2. And then I'm going to take this constant term and I'm just going to move it out of the way for a minute. I can't get rid of it, just algebra. I can write it any way I want. So the part that I'm going to really be focusing on to complete the square is this binomial right here. So I'm going to rewrite what I have, and I'm going to leave some room so that I can complete the square. So the example I just happened to pick when I was demonstrating a perfect square trinomial, if you look, it just happens to be kind of what I need to be able to complete this particular square. I know that if I added a 16 right here, then I would end up with this perfect square binomial. So I'm going to add 16 here. Now, keeping in mind the rules of algebra, I'm never allowed to just randomly add something either on one side without adding it to the other, or if I add it, if I go ahead and subtract it over here, then I'm net adding 0 to the whole thing. So I just need to be mindful that I added 16 to complete the square, but there is this 2 out here, that 16 in the long run is going to be a 2 times 16 or 32. So I added 16 here, so as long as I subtract 32 here, basically I did plus 32 minus 32. I added 0 to my equation, which is totally legal. So that's okay. So I've completed the square, but now I need to factor this thing. So now I'm going to come down, and I know that x squared plus 8x plus 16 is x plus 4 squared. So I'm just going to rewrite it like that. And then now I'm going to combine like terms, and 7 minus 32 is minus 25. So lo and behold, I have a parabola in vertex form. I have my h, I have my k, and I have an a value. And so I could tell you this thing is 4 to the left, down 25, and with a 2 outside of there, that's going to be a vertical stretch. Yeah. So that is a slowed down version of completing the square.